Good morning, all. So good morning, everyone. So successfully we have finished 4 modules. So today we are going to start 5th module, so which is unsymmetrical bending and shear center. Okay. So let me share the screen so we can discuss this. Right. 1 second. No? Yeah, so good morning, everyone. So I think students are around 19 students. Yeah. So we are going to start 5th module. So let me share. Okay. Yeah. Okay. So module 5. So which is unsymmetrical bending, right? So after going through this topic, we are going to start very important one, which is called as the shear center. Okay. So these 2 topics which we are going to cover in the 5th module, isn't it? So now, before going into this, module, so let's discuss first, what do you mean beam, how beam bends, okay, how different this unsymmetrical bending is going to be, okay. So let us take the beam, so which we have already studied in your strength of materials 1, right? So beam, so which is having a longitudinal axis, and the cross section of the beam is like this, okay. So if the beam is subjected to load, right? So what happens? So there will be a uniform bending which takes place in the beam. So where beam will bend in which direction? Beam bends in which direction, Amma? Will the beam bends in X direction or Y direction? Chapali. So when the beam is subjected to loading, okay, so when beam bends like this, in which axis the beam is bending? In which axis beam is bending? So the beam is bending in Y direction, okay. So this is called an uniform bending, which is taking place only in one direction, okay, right? So this will happens only for the sections which are symmetrical in nature. Let us take a square section, right? So let us take a square section, rectangular section, circular section, and I section. So I consider these are symmetrical sections. Why these are symmetrical sections? Why these are called symmetrical sections, Amma? So the x-axis and y-axis of these sections are symmetrical, isn't it? Yeah. If you cut the section in y direction, so there will be an equal halves. If you cut the section in x-axis, even you can find the equal halves, isn't it? So by that, I can consider all these sections are symmetrical in nature. So when these sections are subjected to bend, so they bend uniformly, where your main neutral axis and the bending axis will be what? What happens? Will be same even after bending. Okay? Understand? And it will bend in only one direction and that direction is y direction. So that is the reason why you are calculating the deflection of the beam in only in y axis. Okay, so that's how your bending is called as a pure bending, where bending will takes place only in y direction. So this happens especially for all symmetrical sections. Understand? Now we talk about the unsymmetrical bending. What do you mean unsymmetrical bending? Unsymmetrical bending is nothing but when a beam is subjected to load not exactly perpendicular to the plane. Okay, so if the beam is having a load which is having some inclination, if the load is with some inclined in nature with respect to its angle, so definitely beam will bend in both the axes, x and y axis. Okay, so that kind of bending is called unsymmetrical bending. Okay, don't worry guys, I will try to show it you in an animation mode where you can able to understand what do you mean an unsymmetrical bending. Okay, so before that, just we'll have a look of what do you mean symmetrical bending and what do you mean unsymmetrical bending. Okay, so this is what symmetrical bending. Symmetrical bendings will happens for the sections which are symmetrical in nature. And what are unsymmetrical sections? What are unsymmetrical sections? Let us take an I section, so which is like this. Okay, is this symmetrical or unsymmetrical?
Unsymmetrical.
In which axis is this I section is unsymmetrical?
X-axis.
Very good. In x-axis, this is unsymmetrical. So the centroid won't lies in the neutral axis. So here all neutral axis will lie within the centroid of the section. But here the neutral axis and centroid won't lie in within the section. Okay. So centroid will be somewhere here and the neutral axis will be here. So in that way, let us take another section. So which is a C section. So now tell me, C section is unsymmetrical to which axis?
Y-axis.
Very good. So C section is unsymmetrical towards y-axis. Let us take T section. So T section is unsymmetrical towards
X-axis.
X-axis, right? Even a rectangular section which is a hollow in nature, like this. So in which axis this is unsymmetrical? X-axis. So like this, you can consider taken another section which is an angular section. Angular section is unsymmetrical about
Both the axes.
very good, both the axes. Okay, so this is the centroid of the section and this is the centroid of the angle. So where it will have a shear center. Let's discuss that in detail. Okay, so these are unsymmetrical sections. So basically these unsymmetrical sections, when they are subjected to load, obviously, so these will be subjected to unsymmetrical bending. Understand? So these are unsymmetrical sections. So basically unsymmetrical sections undergoes unsymmetrical bending and symmetrical sections undergoes just bending when the load is perpendicular to the longitudinal axis. When the same load, if it is inclined or the same load which is having an inclination, even symmetrical sections also will undergo unsymmetrical bending. Understand? So that is what we have to understand. What is unsymmetrical bending when it happens? So for a normal unsymmetrical sections, for any kind of load, beams will undergo unsymmetrical bending. But for symmetrical sections, when the load is an inclination, so that has a unsymmetrical bending towards x and y axes. Understand? So that is what about unsymmetrical bending. What happens when the beam is having an unsymmetrical bending? Right? So you need to know. So when the beam is not having any unsymmetrical bending, beams just bend. Okay? So it will have only a deflection. But for unsymmetrical bending, when the beam is subjected to unsymmetrical bending, along with the deflection, beams will have even torsion also. Understand? Beams will undergo torsion. What do you mean torsion, amma? Torsion ante enti? Twisting. Twisting with respect to angle. Okay, with respect to angle. Understand? So that is what unsymmetrical bendings are, undergoes torsion along with deflection, right? So that is what about unsymmetrical bending. So due to this, we have to study an important topic which is called shear center. We have to study the shear center also. Why? Because just a clue is why? Because when you transfer load to the center of the section, the member will undergo torsion. To control the torsion of this beam, you have to transfer load through the shear center, not through the center of gravity. When you do that, definitely you can control the torsion of the beams. Understand? And it's so simple. Concept endante basically for these unsymmetrical sections, along with the deflection, there will be a torsion. If you want to control the torsion of the beam, what you have to do, you have to transfer load through shear center, okay, to control the torsion. Me andarki center of gravity telusu, right? You all know what do you mean center of gravity, but what do you mean shear center? That we have to know. Okay, center of gravity is different, shear center is different. What is the difference between these two? That we are going to understand when we study the shear center. Okay, so we transfer load through the shear center to control the torsion of the beam. Understand? So now let me show you a small video, so which is around 5 minutes of video, where you can able to understand what do you mean symmetrical beam and what do you mean symmetrical bending. Okay, by that we can go into the topic in detail. Okay na guys? Okay, so at least have you got the glance of what do you mean symmetrical sections and what do you mean unsymmetrical sections? Clear? So can I show you the video? Guys, ardhamainda? Guys, please respond. Have you understood what do you mean unsymmetrical bending? What is the difference between symmetrical sections and unsymmetrical sections? Guys, please, anyone?
Yes, sir.
Okay, right. So now let me show you a video, so which gives a clear idea on what is symmetrical and what is unsymmetrical bending. Yeah, here is the video.
See the difference between symmetrical bending and unsymmetrical bending. Okay. So first of all, what is symmetrical bending? I will explain you an example. Suppose, let us say you have a cantilever beam having a rectangular cross section, which has rectangular cross section has two axes of symmetry. This is your x-axis, symmetrical with respect to x-axis, and you also have, this is a y-axis, in particular y-axis. Now, if the beam is subjected to load as shown in figure here, if these loads, if the plane of loading, this is a plane of symmetry. And there's a rectangular plane is the plane of loading. If the plane of loading and the plane of symmetry coincides with each other, then such a bending is called symmetrical bending. You see here, plane of loading.
Okay, guys, have you all understood this? See, let us take a symmetrical section, symmetrical rectangular section, which is in a cantilever way. Okay, so it's a cantilever beam. So you can see the rectangular section which is symmetrical to x-axis and this is the plane of symmetry with respect to y-axis. Okay, this is the plane of symmetry. So here what happens when you apply your load? The load is coinciding with the plane of symmetry. Kada? Ippudu chudandi load anedi మీ plane of symmetry కి coincide అవుతుంది. రెండు coincide అవుతున్నాయి. So that is what he's saying. Plane of loading. So this is the plane of loading coincides with the principal plane. This is the principal plane or plane of symmetry. Okay. So when the load is coinciding with the plane of symmetry, those beams are called symmetrical beams, or those beams will be subjected to symmetrical bending. Understand? So now you can tell me in which direction this beam will bend, in which axis this beam will bend. Guys, when the plane of symmetry and the load is coincides each other, in which axis your beam will bend?
Y-axis, sir.
Only y-axis. So there is no x-axis deformation or deflection taking place. Understand? So this is what symmetrical bending under them. Okay, so let's continue.
Coincide with the principal plane or plane of symmetry. Okay, now in this case, if you see this unloaded structure, after loading it is going to deflect like this. Now initially you had your x-axis here, symmetrical x-axis, and this is the y-axis. Now if you see the y-axis of undeformed structure, and this is a deformed or a deflected structure. Now here your x-axis. Now this is the deflection delta, but y-axis did not change; it remains same. That means the beam has experiences deflection only in vertical direction. Such a bending is called symmetrical bending. You can easily, if you want to find out stresses at anywhere in the cross section at any point, you can use simple bending equation that sigma is equal to M/I into Y, right?
Yeah. So this is what pure bending equation which we derived in your strength of materials 1, isn't it? See, we all should know the vertical deflection will be with respect to x-axis, right? The horizontal displacement will be with respect to y-axis. Avuna? So here you can see it clearly. The y deflection, okay, is happening with respect to x-axis. So this is the x plane. So your beam is bending in y direction, okay, with respect to x-axis, where you can able to calculate the deflection delta. But you can't see any kind of y-axis deformation where you can't see any x deflection. Understand? In x-axis there is no deflection at all. Okay, there is only a y deflection with respect to x-axis. Understand? So this is what is symmetrical bending. So how to calculate this symmetrical bending stress? With the help of pure bending equation. What is a pure bending equation? M/I is equal to sigma into y. Okay, from this you can calculate the bending stress as bending moment by I into y, right? So this is what a symmetrical bending means. Okay guys, so now let's talk about unsymmetrical bending. Okay, let's continue.
This is symmetrical bending, right? Remember this load, this vertical load here, whatever the load that we applied, this load is going to cause bending only about x-axis, because if the load is passing through the y-axis, it will not create any bending about y-axis, but it will create bending about x-axis. Now, what is unsymmetrical?
See, you have to be very clear even in the competition exams also. Okay, in symmetrical beams, or when the beam is symmetrical bending, your deflection will be in y direction with respect to x. Okay, understand? With respect to x. Okay, so adi meer ardham chesukondi. Andagani, so you can't, so don't get confused. So there will be a deflection in y direction with respect to x-axis. There won't be any deflection in x direction with respect to y-axis. Okay, so that is very clear. Okay.
Now see, we take it. Now this is your x-axis, central x-axis, the central y-axis. Now let us say this is an inclined plane, it's a plane of loading. Let us say you are applying a load at an inclination of theta. This is theta, this angle is theta. If you see the cross section, it will show like this. You have x-axis, and this is the radial load that is acting.
Guys, one point here I would like to tell you. See, you should be very clear in any beam, whether the load is vertical or inclined. You should observe that load always will pass through the centroid of the section. Okay, that is very clear. Even if you apply load with an inclined way, with an inclination, or even if you apply load vertically like this, that load also will pass through the center of the section only. Understand? Okay, so that is how the load transfers through the center of the sections. Then beam starts bend. Okay, so here even the inclined load also, this inclined load is also passing through the centroid of the section. Understand? Okay, right.
An angle of theta with respect to y-axis, but this load is passing through the centroid. Remember that this load is passing through the centroid. Okay. Now, if you see the deflection, now you see here in the plane of loading, this is the yellow color is the plane of loading, is inclined to principal plane. This is one principal plane, this is another principal plane. So if the plane of load is inclined to the principal plane, but passing through the centroid, this line of action of the load is passing through the centroid, the resulting bending is unsymmetrical bending. Now you see here, this is the representation. Now after application of the load, it is going to deflect like this. Here if you see, the x-axis originally was here, it has moved to here x dash, and y-axis originally was here, moved to y dash. So the bending is taking place simultaneously about x-axis and y-axis. So if you want to find out sigma will be bending about x-axis plus bending about y-axis. You want to find out. If you want to find out stress at any point in the cross section, you have to add bending about x-axis, bending about y-axis, because you can resolve this inclined force that is theta as vertical load P cos theta
and P sin.
So this will produce bending about the x-axis. Now horizontal load P sin theta. This P sin theta will produce bending about this y-axis. So that is, you can, if you add these things together, you can find out stress at anywhere in the cross section of the beam.
Right, guys? Have you all understood what do you mean unsymmetrical bending? Right? So here you can observe carefully. So this is the deflection where y deflection, and this is the deflection with respect to x deflection. Okay? So when the beam is subjected to an inclined load, okay, where the load is passing through its center, so definitely beam will undergo bendings in both x and y axes. So these kind of bending, we call it as an unsymmetrical bending. Okay, so this is what an unsymmetrical bending, okay, we used to consider. So here you can, how to calculate that unsymmetrical bending, as he told, your bending stress is equal to bending stress in x direction plus bending stress in y direction. Okay, how to calculate this based on the load? So originally load is P. Kada? When the load is inclined, you have to resolve the force into two components with respect to angle of inclination. By that, the vertical force will become P cos theta and the horizontal force will become P sin theta. So with respect to these two forces, you have to calculate the resultant bending stress. Okay, this is called resultant bending stress, which we are going to calculate. Okay, right. So let's continue.
So this is called unsymmetrical bending. Remember, this load should pass through the centroid. Otherwise, it will produce, in addition to bending, it will also produce torsion. Okay. Now, suppose if you take an unequal, otherwise it will produce, in addition to bending, it will also produce torsion. Okay.
1 second, guys. I would like to share one point here.
If you add these things together, you can find out stress.
Yeah. See, here one important point where you need to be clear. So when the beam is subjected to unsymmetrical bending, okay, with this inclined load, so even that your centroidal of the before bending and after bending should always coincide. Compulsory the coincide avval. Understand? So this should always coincide. Okay, before bending and after bending. Okay, even though you will get deflection in both x and y axes, but the centroid of the section should not change. Should always coincide. But there is a question, sir. If the centroids of these two planes are not coinciding, means what happens? Then torsion comes into picture. Understand? So the centroid of the plane before bending, after bending, if they are not coinciding, so then your beam will undergo torsion also. Along with bending, it will undergo torsion. So for which kind of sections it will usually happens? And torsion will happen for T section, angular section, C section, and I section, which is unsymmetrical. Understand? Why? Because for these sections where there are unsymmetrical in nature, when you apply load, definitely the centroid of the plane before bending will not coincide with the centroid of the plane which is after bending. So that is why these unsymmetrical sections will undergo torsion along with bending. Understand? Bending to part of torsion kuda untundannamata ee unsymmetrical sections ki. Okay, understand? So that is the reason why to control this torsion, what we have to do, we have to transfer the load or we have to apply the load, okay, not through the center of gravity. Ikkada chudandi, load how it is passing. The load is passing through the center of gravity. Understand? Okay, for these kind of unsymmetrical sections, if you pass the load through the center of gravity, you may see the torsion in the member. Torsion ante you may see the twisting in the member. To control this twisting, what you have to do, you should not pass load through center of gravity. You should pass load through shear center. If you pass load through the shear center, you can control the torsion in the beam. Okay, torsion in which kind of beams? Torsion in these kind of beams which are unsymmetrical in nature, like T beam, angular beam, channel beam, I beam. Ilanti beams lo manam torsion chodakodadu ante we have to pass load through the shear center, not through the center of gravity. Okay, so that is what the concept of unsymmetrical bending and shear center. Clear? Ippudu andarku arthamainda, right? So now let's continue. So by that you can understand more clearly.
At here in the cross section of the beam. So this is called unsymmetrical bending. Remember, this load should pass through the centroid. Otherwise, it will produce, in addition to bending, it will also produce torsion. Okay. Now suppose if you take an unequal angle section, here these are section with two symmetrical axes. Now here we are having an unequal angle section which will have a shear center at this point, which has, let us say, the load is external applied load is passing through the shear center. This point is a shear center. Remember, shear center is the point. If the load is passing through the shear center, there will not be any torsion or twisting produced in the cross section of the beam. Okay. Now, this is your central x-axis for this angle section. This is the central y-axis of the angle section, right? Now, this is a major principal axis, and this is the minor principal axis, right? Now you see your applied load P or W per meter is inclined with respect to major principal plane or minor principal plane. That is why this will produce unsymmetrical bending. Today we will see the difference between, and this is the minor principal axis, right? Now you see your applied load P or W per meter is inclined with respect to principal.
Okay, so now what you understand from this? What you understand, guys? So let us take an example of an angular section. First of all, we know angle section is an unsymmetrical in nature. Tada? So this point is center of gravity of angular section, right? So you can see it clearly. Your center of gravity is not coinciding with the shear center. See, if let us take, if I pass load through center of gravity, if I apply load here instead of here, what happens? This angle section will bend and it will also have a torsion, and it will also twist. Understand? If I pass load through the center of gravity like this, okay, if I apply load here, it will bend and it will torch, it will twist. To control twisting, I have to pass load through the shear center, not through the center of gravity. If I pass load through this shear center, what happens? It will only bend. Okay, it won't have any twisting. Understand? And one more thing, how this angle section is considering as unsymmetrical bending. Din enduko unsymmetrical bending antunnamo? Why? Because you can see this is the x-axis and this is the y-axis. Okay, so this is the major principal axis and this is the minor principal axis. Okay, so you can see the load is not passing through the center of gravity, right? So the load is making some angle with the major principal axis. So that's why whenever the load is not passing through the center of gravity, when the load is making with some angle, so definitely these kind of sections will undergo unsymmetrical bending. Understand? So this is what about concept of unsymmetrical bending for the both symmetrical sections and unsymmetrical sections. Okay. Additionally, these unsymmetrical sections will undergo torsion along with the bending when you are not transferring load through the shear center. Okay. If you transfer load through the center of gravity, even unsymmetrical sections also will undergo torsion, right? So to control the torsion, you have to pass load through the shear center, not through the center of gravity. Then only you can control torsion. Understand? So this is what the concept of unsymmetrical bending. Okay, guys, any doubts? I hope you all understood about unsymmetrical bending and about the shear center, I think. So if you all aware about this, by that we can start what are the reasons of unsymmetrical bendings and what is the formula for calculating how to calculate the unsymmetrical bending resultant stress with respect to X and Y, okay, in the next class. So please tell me, have you all understood the concept?
Major principal plane or minor principal plane.
Guys, please answer. Have you all understood or not? ఏమైనా డౌట్స్ ఉన్నాయా? Guys, please respond. అందరికీ అన్సిమెట్రికల్ బెండింగ్ అంటే ఏంటో అర్థమైందా?
ఒకసారి చెప్పండి సార్ మళ్ళీ.
సారీ,
ఇందాక టాపిక్ ఒకసారి మళ్ళీ చెప్పండి సార్.
See, సిమెట్రికల్ బెండింగ్ కి అన్సిమెట్రికల్ బెండింగ్ కి డిఫరెన్స్ ఏమి లేదమ్మా. The main point is here you can understand it clearly. Symmetrical bending of a beam ante, which is also known as uniaxial bending antar. Okay, so which occurs when the load plane coincides with one of the main axis of the beam cross section. So that beams are symmetrical bending beams antar. If the same beam, when the load is not passing through the or not coinciding with the direction of the load or not coinciding with the any plane of the beam, okay, so those beams will undergo unsymmetrical bending. అర్థమవుతుందా? సో దట్ ఈస్ వెరీ క్లియర్. సో మీకు ఇందాక చూపించిన ఎగ్జాంపుల్ కావాలంటే మీరు ఒకసారి నేను ఇప్పుడు చెప్పిన లెక్చర్ యూట్యూబ్ అప్లోడ్ చేస్తాను, మళ్ళీ ఒకసారి గో త్రూ అవ్వండి. ఓకే, సో లెట్ us take a beam. So this is your x-axis and this is your y-axis. Okay, so and let us take another beam, x-axis and y-axis. Okay, so if you apply load like this, when the load is passing through or when the load is coinciding with the plane, okay, this is the principal plane, this is the major principal plane. So when the load is coinciding with the major principal plane, so these beams will undergo symmetrical bending. This is symmetrical bending under. Let us take a load here like this. Okay, so definitely this load is also will passing through the center of gravity, but this load is not coinciding with the any plane in the section. ఈ లోడ్ అనేది x axis తో కానీ y axis తో కానీ కోయిన్సైడ్ అవుతుంది.